in some of the earlier videos, we've seen that when given y equals one block plus another block, if you want to find out dy by dx of this thing here, you would just concentrate on differentiating this one. If you differentiate this, it will give you 12x squared, and then we would concentrate on differentiating this one, which will then give you 10x. So if you want to know dy by dx, then you would just simply add the two together. Okay, so in general, if you're given y equals one block, add another block, and you could go on. You could add more blocks here if you wanted to. But in general, if you're given y equals one block plus another block, and if you want to find out dy by dx, then just concentrate on differentiating this. Okay, that would then give you this, and then concentrate on differentiating this, and then dy by dx is given by the sum of the two. Okay, so you would get the two added, add them up together. How is it that we know this? How is it that we know if you want to differentiate this, you can just simply add the two together? So in this video, I will show you how it is that you know this. Okay, so start by looking at your line. Let's say this line here. This line here is u of x plus v of x. So remember, your line could be anything. It doesn't. It will. We don't know what this will look like. So let's just draw any line and then set up 2 points A and B. So draw any line, set up 2 points A and B, and then say to yourself that the gradient that exists between A and B is given by this thing, take away this thing, and then divided by h. H is this length here. Okay, so don't forget, if you have x plus h, which is this point here, if you put x plus h into here and into here, that will immediately take you to here. Okay, so if you want to know, if you know x plus h to be here, if you put it into this thing here, if you put x plus h into this thing, it will immediately take you to here. So this height here is given by this. Okay, and then suppose you're at x here. If you put it into here, then that will take you straight to this point here. So if you want to know this height here, don't forget the gradient here is this height divided by this divided by h. This length here is h. Okay, so if the gradient that exists between A and B is given by this height, it's given by this height here, which is this whole thing here. Take away this height, which will then give you this height, and then divided by h. Okay, so the gradient that exists between A and B is given by this. But then the true gradient remember that the line that joins A and B is what's called your secant line. Okay, this here is your secant line. And then if you start to decrease h, then your secant line eventually becomes your tangent line. So if you want to know the gradient at A here, then create your secant line and then slowly decrease h, and then eventually your secant line will become your tangent line. Okay, and if you don't understand this, watch some of the earlier videos. So remember that y is the combination of the two here, the sum of the two. Start out by setting up 2 points A and B, and then say to yourself the gradient that exists between A and B is given by this here. But then the true gradient is when you start to take the limit of the whole thing. So the true gradient, which is dy by dx, the true gradient is when you take the limit of the whole thing. Now, if you look at this here, this then simplifies to this, because there's nothing really going on. We don't actually need the squared brackets here. The reason why we put the square brackets in is to illustrate that this height here is given by this whole thing here, but we don't actually need the square brackets. And then this block here is given by this. That's why we have the square brackets, just to illustrate that this thing here is basically this height here. This thing here is basically this height here. Okay, so remember, the gradient that exists between A and B is given by this. Then the true gradient is when you start to take the limit of the whole thing here. Okay, now let's tidy up this limit. Well, here it's just minus this, so that becomes minus u of x, and then a minus a positive, that will give you a minus v of x here. So there's nothing special that's going on here. It's just you simplifying it. There's nothing in front, so this block here becomes this block here. This block here becomes this block here, and then this here becomes this here, and then this here becomes this here. So at the moment, hang on. At the moment, you've got one block here plus another block here, and then take away this block, take away this block here. So let's move. You see this here is a u. This here is u, and this is a u. So let's move this block next to this u here. So it's us moving this block over to here. Okay, so this block here stays the same, and then we're going to move this block here to over here. Okay, and this v x plus h here is this bit here, and this stays the same. Okay, the point is that I want you to visualize it like this. So here's one block, and here is another block. Okay, now break up these two. Break up this one fraction here. At the moment, you've got a fraction in a way. Break up this fraction along here. So you've got two fractions now. You've got this here, and then this here. If you were to add these two fractions together, the two denominators here are the same, so you can just simply add the two together. So my point is, break up this fraction like this, so it becomes this. Now, this, so at the moment, this whole thing here, we can visualize it as two separate fractions. Okay, two separate fractions, and then the limit. Well, by using one of the laws of limits, the limit of this here. Well, at the moment you've got the limit of this whole thing here, so you can actually break into this here. It's one of the laws on limits. So if you don't understand this, watch some of the early videos on limits. So from here it would take you to here. So now you can visualize it like this. You've got one block, add it to another block. Okay, and then, well, this thing here is really the definition of this here is really your gradient in a way. Your du by dx. Okay, because yeah, du by dx is really well, this is the true definition of du by dx. So this thing here is this thing, and then this here is well, this is your true definition of the derivative. So this bit here is basically this. So that's well, then overall the dy by dx is given by this by you working out the derivative. So it's just basically, well, this is the derivative, this is the derivative. Then you can simply add the two together. Okay.